Hey everybody, Tom Cherryholmes here with the FujiNet project, and here is our second video in a two-part series on writing a light cycle game in BASIC. In the first video, I showed how to write the core game logic and to produce a simple light cycles game written entirely in BASIC that can be played with two joystick controllers. Now, we are going to extend this code and modify it as needed to add the ability to play this across two computers connected via FujiNet. Recall that the last thing that we did here was see our completed light cycle game working as expected. And then some. So now we need to go into graphics mode and start adding in the bits and pieces that we need to implement network functionality. And as you see, it won't be that much. To start, our game immediately goes to line 100, which starts the game logic. We actually need to take a little detour and ask for a host name, if not player names, ahead of time. To do this, we'll make a new section of the code starting at line 3000. First, we'll go ahead and make a goto to 3000. And then we'll start actually writing our new code in earnest. To start with, we need to clear the screen, and we need to dimension some variables. To start, we need variables to hold the host name and the device spec derived from that host name. We also need the names of the players, A and B. We need a sort of scratch pad, which I'm calling Q. And we need variables to hold a message that is whether or not a player wins or draws, and the same number of characters that are in M as spaces in N. This is essentially all we need in our dim statement. The next statement gives us a little title. Simple enough. I mean, nothing too extravagant, and I'm just eyeballing where this is going to go. And we need a prompt. So we're going to add a little blank space here in between. We're going to add a prompt. And as the prompt indicates here, we are going to either ask for a host name, or if you press enter to listen, then no host name is actually recorded, and we will take advantage of that fact to determine whether or not we need to connect or to listen. We go ahead and derive our device spec, and our device spec begins with N:, which is equivalent to N1:, and we're using the TCP protocol, so we begin with TCP://. We then append on to the end of the string as it exists at that moment our host name, if it's there. If it's not, it will be blanked and this will be skipped over basically. No big deal. We need to then end the host name with our port number, which begins with a colon and ends with a slash. That is everything that we need to do to construct our device spec. We then go to line 3040 and immediately try to open the connection with the D variable that we just derived. Now, because I'm testing this against netcat on my Unix machine here, or on inside of my WSL environment, I've chosen to set the line feed translation mode to line feed, which is 2. If we're playing against an Atari, then this value should be 0 to do no translation at all. We then immediately go ahead, and if we're not listening, then we go ahead and ask for a player 2 name. We go sub to 2100, which we will implement in just a moment. And once we return from 2100, we immediately go to 100, which starts the game logic. Otherwise, if we are listening, then we assume that this is player 1 we're needing to get a name for. And we input A. Otherwise, pardon, I did not mean to say otherwise. Then we immediately try to wait for a connection. We indicate to the user that we are waiting for a connection. And then immediately afterwards, we do a status. The status will return back 4 bytes indicating the status of the connection and if there are any bytes waiting. The value that we're interested in is location 748, which contains whether or not a connection is waiting for us to accept. If this value is 1, then we are waiting for a connection to accept. Otherwise, if the value is 0, then we immediately loop back to 3070. This allows us to keep spinning in this particular loop very quickly and catch the connection as soon as it's available. Once we break out of this loop, we have a connection to accept and we need to accept it. We use an XIO command, and we use XIO command number 65 to accept the connection. And again, we use the same values that we used in the open to pass to 65 to accept the connection. So if I'm using 2 up here, then I also need to use 2 down here as well. We go ahead, we go sub to 2100 again, and then we go ahead and end this whole segment by jumping to the game logic. That's everything that we need to do to capture a host name, put ourselves into listening or connect mode, do the connection or listen, wait for a connection if we're listening, then finally accept the connection if we are listening, and then go to line 2100, which we're going to see what this actually is in just a moment. And then when we return from that, go back to the game logic. If we look at what's at 2000 to 2100 right now, there's really not much here at all. But this is where we can easily store subroutines that we can use to our advantage. We'll go ahead and we will store. We'll start at 2100. We'll go ahead and trap 2130 in case something goes wrong, but if we are listening, which we know because we are setting ls to a particular value, again, look at line number, let's see, hold on a second. Wait a minute. I realize that I'm doing something ever so slightly wrong here. My bad. I need to add an additional line here. If h is blank, then ls equals 1. Simple enough. Boom. That's good to take. That fixes that issue right there. Sorry, sometimes I miss things taking and going over my notes here. I hope you guys have a bit of patience as I try to explain this as best I can. Moving on, we need to implement line 2100, or rather the block of 2100. We start by trapping to 2130 for reasons we'll get into in just a few moments. And we will immediately follow that up with if ls, then we output player A's name, and we immediately wait for player 2's name and put that in B. Otherwise, if not ls, then we do the opposite. We immediately take and return. Now let's think a bit about what this actually does. When we call this, this immediately causes one of the player's names to be output, followed immediately by waiting for the other player's name to be echoed back. Because inputs are a blocking call, that is, if you do an input, it will wait for input until something happens. Either one of two things must happen. Either we must receive some data, or the connection disconnects and we get an end of file. This allows us to synchronize the connection and to get both of the machines to the same place. It makes implementing the protocol that's coming ahead much simpler, because we only need to essentially, since we know that we're starting from the same time and the same place, then all we need to transmit are direction differences. We can really cut down on the amount of network traffic that we need to send, and therefore make the game a lot more responsive, even in BASIC. But I digress. Let's continue. So this is essentially the first part of the logic here. And we have the first little bit of our logic right here, and we can actually go ahead and see where things stand at this moment. We'll go ahead and open up another window here on my Unix box, which is essentially my netcat window. And in our case, I'm going to have the PC here answer the connection. It's going to sit here, it's going to wait for a connection. And we're going to try this out. Okay, we see that our game has now gone into our little intro here. Enter hostname or return to listen. I put in the host name of my PC here, and immediately we get a connection from the FujiNet, and netcat lets us notice of this fact. I go ahead and enter my name, and you can see that the name immediately gets sent over, and it is now waiting for a reply back from the other side. Again, this is all in the case of synchronization. And all it's waiting for is a player name. So I go ahead and give it one. And we see right here that the game starts. Looking good so far, what don't you think? So far, so good. Now one of the side effects here is I can go ahead and just hit stop, and this socket is still connected. I can sit here and wait right here. We can keep this socket connected, and we can simply go to 100 to continue the game. And it will gladly do so. So let's go ahead and add the next major piece that we need. If we look at the loop as it exists right now, we'll see that it has all the bits and pieces that we need to go ahead and basically iterate through the existing loop. We don't need to do too much here. We really don't. But we do need to add a couple of bits for a simple scoreboard. That's simple enough. We can go ahead and add them here. And for this, since we need to output to the text window and we want to do some cursor positioning in the text window, we can't use position because that would assume that we want to change something in the graphics window. So we have to take and poke things manually. We use location 656, which gives us the row that we want to deal with in the text window, and 657, which gives us the column that we want to do in the text window. And what I actually want to do here is center both the player A and player B names, split the window in half, and center each of the players' names within those respective halves. This is how we do it. Pokes don't like floating point numbers, so we need to use integers. And we want to divide the work area that we want roughly in half. And we want to use the length of A, divide that in half, and display the result. So these first two pokes do the position inside the text window, and then we immediately output the result. We do the same thing again. But for B, and we add a bias to actually do this on the right-hand side of the screen. We add an additional 18 characters on the side, and then we output B. Then we do 2 more lines, which output the score. And we use the same technique again. Except this time, since we're dealing with integer variables, and we want to be able to use them as strings so that we can do the string calculations with len, we use str $ here to make this calculation. But we still use the numerical value anyway to output. We just want to be able to position it in a nice, way here. We do the exact same thing. For B. There we go. We take and run the result now by going to 100. We see our score. Now I do think we have a slight problem on line 114. Let's have a look. Huh. Oh, excuse me. I need to do plus 18 here. And there we go. Boom. Getting closer. So that's all we need to do for the main part of the loop here. The next thing that we actually need to do is we need to actually start handling network input and adjusting player directions based on network input. And for that, we're actually going to go up into the top part of the program. And ostensibly, we're going to modify starting at line 16 and change how this whole thing actually works. First and foremost, we want to define a new variable for player direction called PD. We're going to go ahead and set that to 15. PD equals 15. If stick 0, if our joystick has moved, then we need to change what's going on here. This changes here. PD equals stick 0. Get our string for stick value. and immediately go ahead and output our new stick direction. And 17 changes entirely. We're no longer looking for stick 1, but we're checking for network traffic, and if it's there, grab it and put it into a new variable to hold the new direction for the network player. We do this by checking for status. We go ahead and set ND to 15, just like we set PD to 15. And if peak 746 is greater than 0, that is, if we have any data waiting at all, then this value is going to be greater than 0. Then we ask for it. And we put it in a variable called ND. 18 changes as well. And this is the start of a few if statements. And we figure out whether or not we're listening or if we're not, and then put this network direction that we just got into the appropriate player slot, into the appropriate player direction slot. If ND is no longer 15, that is, it has moved, and we're listening for a connection, then the right direction is the one that needs the network direction. However, if direction has moved and we're not listening, then the opposite is true. Then we finally check for player direction changes. If player direction has changed and we're listening, then the left direction becomes the new player direction. And if we're not listening, then the opposite is true. We go ahead and we do a little bit of sound here, just for the sake of argument. We can modify this however we want to do, and to make the sound more interesting, we will do slight variations based on the direction the player happens to be going. Finally, we go ahead and return back to our caller. So that's everything that we need to do to ostensibly handle network input. Let's see where we are at this point. So for this, we'll go ahead and go to 100, and I'm going to go ahead and pair my joystick again because it is turned off during this time. Get it ready. And we're going to move direction. And if everything goes right, we should see the directions show up in the netcat window. Oh, look at that. It's beautiful, isn't it? And you can see, even as we're transmitting, we're not losing all that much. Boom. Everything cool. Go ahead, turn off the sound. So there's the first part right there. We can see the directions being transmitted, and I actually bet if we send some directions back, we should be getting them as well. Let's find out. So you can see. Boom. There we go. It helps to put the right directions in the first place. I am not putting end because end would close our network connection, and I don't want to do that. Not if I don't have to. We go back to graphic 0 here, and we finish this off by essentially handling the winner logic. And the winner logic we're going to put in 2200. If we look at our winner logic right now, it's implemented on lines 1200 through 1400. And you can see there's not much going on here. There's a draw, delay, etc. And I'm just going to go ahead and replace those entirely. Boom, let's just pull them away because all of that's going to change now. The 1200 is going to use our message. Go sub 2000, go to 2200, 1300. And now we're actually going to take and build a message from the player name, append to that a message, and again for 1400, the difference being this. Boom. So now 1200 through 1500 look like this. That's the first part right there. Well, what is 2000? Well, 2000 is a routine that we're going to make the winning a bit more flashy, just to start with. Nothing too big, nothing too small, but I think effective. So we start with line 2000. We go ahead and clear the sound. Then we go ahead and set in to have the same number of blanks as what's in M. Then we do a little loop here. And we put a nice little bit of centered text. Oop, darn it. I have to type that again. 38.2, Lin M. Gosh, what I wouldn't just give to be able to take and cut and paste this. 1 second. Where is it failing? Then MS2. Hold on. MS2. That's right. Bing bing 38, 2. Int 38, 2. Len MS /2. Hold on one moment. Sorry about that. A little misplaced parentheses, basically right here. Okay, so with that, and we'll do the same thing for 2030, the difference being that we're doing in and in. Same thing. Boom. And followed by 2040. Sorry, that's 2030. 2040. 2030. Sound 0. 32. 10. 10. Give a little sound. 2050. Sound 0, 0, 0, 0. 2060. Next in. 2070. Return. And what this looks like when I take and undo it there, that's a nice little message routine. And you can see the result of it here. In fact, we'll go ahead and go into graphics mode and test it out. And you can see it right there. Bam. Just a simple little message routine that takes and does the wins message here. You may have asked, where is 2130? And you would be right. We didn't actually implement it. Let's actually go ahead and deal with it. 2130 is our disconnected line, and you can see that we did a trap 2130 here. And all we need to do here is say disconnected and end the program, which will close the network connections for us automatically. Finally, we need to add some additional logic to say whether or not we wish to play again. Which, if we actually take a look, we can see in 1300, 1200 to 1400, we can see that we reference 2200, and it's the last part of the program that we actually need to implement. Again, pretty simple. We clear the screen, which, since we're in graphics mode, basically means to clear the text window. And we immediately ask, do you want to play again? And we use that little bit of scratch that we used. I used Q for query, asking a question. Do we want to play again? If, again, 2210, if Q, if we say yes, then we immediately try to do a synchronization again, which will send the player names in both directions and put everybody on the same page at the same time again. And then we immediately go back to the game start. Oop. What happened here? Oh, yeah, there we go. 2220, if Q equals N, then we immediately just say, okay, we're disconnected, we end the program, we're done. We already have code for that, so let's just use it. Otherwise, if they entered something we don't really understand, then we go back to 2200 again and ask again. And believe it or not, that's the whole program. And we can go ahead and save that. We go ahead, we save that, we're good to go. And now we can test it. So we can go ahead now. And since we still have a socket connection, we can just go ahead and test it real quick. Sure, okay, yep, sure, why not? And because I did a 1,1 and only checked for the first character, both Y and YES are valid. And in that case, what has happened, we say yes, it has sent Bob again, and it's our job to take and send back the answer. And the game starts again. And so on. So, I mean, in essence, we have everything that we need in order to implement the whole game. We go ahead and say yes, sure, bam, it sends the player name again. And there we go. There's our light cycle game in a nutshell, ready to go. I'm going to finish this video since we just saved the game and we know that this works reasonably well. I'm going to go ahead and finish this video by making this disk automatically boot into our light cycle game. And that's really easy to do. If we go ahead, we can end, and if we type end, it will close the connections and you will see netcat stop. Boom. Connection's done. We're ready to go. All good. We can go into DOS at this point here and see what we have. We have our Light Cycles game, and we have the original copy here for comparison. And we're just going to go ahead and make a little trick make this automatically boot our Light Cycles game using the do command here, which is part of DOSXL. We'll do this by opening up using the copy command. Actually, no, I can't do that here. I don't have copy. So we'll do this from the cartridge. We open a file for writing called startup.exe. Then we go ahead and write our little command. Do. And the first thing we want to do is do car. And then we immediately follow that up with our run command. Now, because quote is a special character, we actually have to do this. Characters for 34, which gives us a quote, D:, cycles. And do the same thing again. Let me actually verify that that is correct. Yes, it is. Okay, great. Boom. We write out our single line, and we go ahead and close. And in fact, if we go ahead and view the result in DOS, we can see our finished command here. Now we're using the do command to invoke car and then run cycles. Watch what happens. So when we boot this disk, it will boot DOSXL, it will load our auto-run sys handler, and then it will immediately run the commands listed in startup.exe, which in this case is our do command, which goes into the cartridge and then runs the cycle game. Let's test it out. We'll do this by invoking a cold start. And you can see right there, it just works. Voila. There's our game from start to finish, packaged up. It can be uploaded to a TNFS server for public consumption. Voila. Furthermore, I will take and finish this by doing this from the other direction now. We will do a return to listen. We will wait for a connection. Hopefully, if this thing behaves well enough, I know I'm testing fate here. And look at that. Boom. Immediately we connected and we got our protocol here. Okay. Now, ostensibly, from the other side, recall that it was asking for player 2 name. So the other side would be asking for the other player name. And there she is. Ready to go. Of course, we're done. So hit no. Disconnected, everything's disconnected, and we're done. Since the server connection was listening, it doesn't just drop the connection back. So anyway, slight implementation detail there. But anyway, so everything that you need in order to implement a light cycle game, implement the core bits and pieces, and then make those resulting bits and pieces networked enabled. I hope this has been informative. And I will be making more of these as time goes on here, but just showing you guys how basically to do efficient and simple network connectivity, even from within Atari Basic here. So until next time, guys, have fun.